Assalamualaikum and hi everyone. In this video we will talk about the geometry of the building that we have choose, which is Muzium Pendidikan Nasional UPSI.
For introduction, Muzium Pendidikan Nasional is the thing that we have chosen to investigate. The reason Muzium Pendidikan Nasional was chosen is that it includes and adheres to the geometrical ideas, shapes and concepts that we covered in our class. Muzium Pendidikan Nasional was built in August 1919 and complete in June 1922. For the location, Muzium Pendidikan Nasional was located at campus Sultan Abdul Dalil Shah, Sultan Idris University of Education, 35900 Tanjung Malim Perak, Darul Rizwan. For the function, Muzium Pendidikan Nasional was established to serve as a central hub for students, researchers, and the public seeking information about education in Malaysia and around the world. It also maintains and restores Malaysia's educational heritage, whether tangible or intangible, through education heritage-based research and development. Lastly, the museum promotes education knowledge by hosting events, seminars, workshops, and lectures relating to the national education. Next, for the size, this building had a floor area of 3,239 square meters. The upper level of this structure served as SITC's main administration center, housing the principal office, staff room, meeting room, general office, composing office, and also library. Meanwhile, the bottom floor houses classroom and the main hall, which is used for monthly assemblies and other. The diagram shows the building of Muzium Pendidikan Nasional.
The geometrical shapes. The Muzium Pendidikan Nasional has two rows of buildings with consisting of two wings, right and left, and this building forming letter H. The floor is composed of cement and wood, and the building is totally constructed using the load-bearing brick wall construction method. Patterned glass pieces provide clear natural lighting during the day. Chinese tiles made up the building's original roof before being replaced with cement tiles. The interior of Muzium Pendidikan Nasional is decorated with many doors. This building has some shapes that consider as geometrical shape from the design of facilities. The first geometrical shape is rhombus. The shapes on the main door of Muzium Pendidikan Nasional are rhombus from the front view. Rhombus is a parallelogram that has two congruent adjacent sides. All sides of a rhombus are congruent. Next, the geometrical shape is isosceles triangle. The shapes on the doors are isosceles triangles. Isosceles triangle is a triangle which the two sides of it are equal in length, called leg. The angles opposite the sides, called base angles, are also congruent. The another geometrical shape is a circle. The shape inside of an outdoor unit is a circle. The white small circle on the outdoor unit as its center. Last but not least, the geometrical shape that we have found in the Muzium Pendidikan Nasional is rectangle prism. The cover of replica inside the Muzium Pendidikan Nasional is rectangle prism. Rectangle prism is a three-dimensional geometric shape.
I will explain the geometrical concepts. Here, we will explain further each shapes of the objects that has been explained in section 2.1. Besides, we will also explain and show the relation between the measurements of each shapes and concept of the geometry that have learned in class. And last, we will find the length and calculate its angles, perimeter, areas, and volumes if exist. The first shape is rhombus. The formula of perimeter for rhombus is P equal to 4A. So here, the perimeter of rhombus is P equal to 4 times 30 cm equal to 120 cm. While the formula for area of rhombus is A equal to d1 times d2 over 2, where d1 and d2 are the diagonals of rhombus. So, the area of rhombus A equal to 40.2 cm times 50.3 cm over 2 and equal to 1011.03 cm squared. The second shape is isosceles triangle. The perimeter of isosceles triangle using formula is P equals to 2 times A plus B, where A is the length of two legs that are congruent and B is the length of base. Thus, the perimeter of isosceles triangle on the door is P equal to 2 times 21 cm plus 27 cm and equals to 69 cm. While the area of an isosceles triangle using formula is A equals to 1 over 2 times base times height. First, we need to find the height B using theorem Pythagoras. B is equal to the square root of C squared minus A squared. And then we substitute C equals to 21 cm squared and A 13.5 cm squared. So here we find the length of B is 16.09 cm. So we can find the area of isosceles triangle on the door. Using the formula, A is equal to 1 over 2 times base times height. So the area is A equal to 217.22 cm squared. The third shape is circle. The formula of diameter for circle is D equals to 2R. And while the formula for radius is R equal to D over 2. So here we can find that the radius of circle is 24.25 cm. We also need to find the circumference of circle C equal to pi D, and we can find here that the circumference of circle is C equal to 152.37 cm, while the area of circle given by the formula is A equal to pi r squared. And we can find out that the area of circle is 1847.45 cm squared. The last shape is rectangle prism. The length for rectangle prism is L equal to 57 cm, the width equal to 40 cm, and the height equal to 20 cm. The formula for surface area of rectangle prism is A equal to 2 times the length times width plus 2 times length times height plus 2 times width times height, while the formula for volume given by V equal to length times width times height. Here we can calculate the surface area of rectangle prism using the formula given. We need to substitute the length equal to 57 cm, the width equals to 40 cm, and the height equals to 20 cm to the formula. And we can get the surface area of rectangle prism is A equals to 8,440 cm squared. And the same also with the volume, which is V. We need to substitute its length, width, and height respectively. So we can get the volume of rectangle prism is V equals to 45,600 cm cubed.
Now, we will move to transformation in motifs and patterns. For geometric transformation, there will be some changes that happen in any given geometric shape. For transformation, a geometric change in position, which size and shape will remain the same, unless for dilation, or we can say it enlargement or resizing, the shape will remain the same, but only the size will change. So basically, there is 4 types of transformation, which is the first one is translation. The shape will move in both a horizontal and vertical direction. For the size, shape, and its orientation will remain the same. The second one is rotation, the motion of an object that involves a center, an angle, and a direction of rotation. And for the size and shape will also remain the same. And the third one is reflection, or known as flip. An image will reflect or flipping across a line, or known as line of reflection, to form other image. So the size and the shape will also remain the same. And the fourth one is dilation, or known as enlargement or resizing of an image. Image may be increased or decreased based on the scale factor and center of dilation, and the size will change while for the shape and its orientation will remain the same. Now we will look at the concept of transformation that exists in the motifs and patterns in Muzium Pendidikan Nasional UPSI. For the first transformation is reflection. And as you can see, the concept of transformation of reflection that exists in patterns exists in triangle shape, where the triangle shape is reflect on the axis of reflection and it form another triangle shape. And as you can see also at the motifs, the concept of transformation that exists in motifs is in rectangle shape, where the rectangle shape is reflect on the axis of reflection and it form another rectangle shape. Next, we will look at the concept of transformation in dilation that exists in the patterns in Muzium Pendidikan Nasional UPSI, where the geometrical shape that exists is in triangle. At first, the triangle is reflect on the axis of reflection, and then where it form another image, and then where the dilation happen, as you can see in the figure, where the pre-image is in small size and then image is in the big size. And then we know that whenever the pre-image is in small size and image is in big size, where the enlargement happen based on the scale factor and the center of dilation. Alright, so lastly, we will look at the concept of transformation in dilation that exists in the motifs in Muzium Pendidikan Nasional UPSI. As you can see, where the geometrical shape that exists is in rectangle. And then as you can see at first, the rectangle is reflect on the axis of reflection and it form another image. And then as you can see also at the figure on the slide, where the pre-image is in small size and the image is in big size, where we know that whenever the pre-image is in small size and the image is in big size, where the enlargement happens or exists based on the center of dilation and the scale factor.
To summarize, Muzium Pendidikan Nasional is the thing that we have chosen to investigate. Muzium Pendidikan Nasional was built in August 1919 and construction was completed in June 1922. The main usage of this museum was to be the central source of information for students, researchers, and the public about education in Malaysia and internationally. But technically, there are a lot of other usage of Muzium Pendidikan Nasional, such as maintaining and restoring education heritage in Malaysia, either in tangible or intangible form, through R&D based on education heritage, and many more. The floor area of this museum is 3,239 square meters. This building has a combination of geometrical shapes such as a rhombus, a triangle, a circle, and a rectangle, which can be found at the door or all around the museum. For example, a rhombus and a triangle can be found at the door of the museum and have their own measurement and concept of geometry. The motif and the pattern of a rhombus can also be related to concept of transformation such as translation, rotation, dilation, and reflection. In conclusion, this task has helped us gain so much knowledge about buildings at University Pendidikan Sultan Idris. This also gave us a lot of realization about what happened around us. For example, before we ran this task, we may not have realized how many geometrical shapes were around us at University Pendidikan Sultan Idris. But now, we realize that there are a lot of combination of geometrical shape that can be related to all the concepts that we have learned in geometry SMG3013. These tasks have helped us realize that knowledge is everywhere. It's not only found in the book, but also surround us.